This is section 3.3, more graphing of lines. We're going to talk about x and y intercepts and horizontal and vertical lines. The x-intercept is the place where your graph crosses the x-axis. If we're looking at this line, our x-intercept is 5, because that's where the line crosses the x-axis. The y-intercept is the place where the graph crosses the y-axis. Our y-intercept would be 2 here. If you want to solve for your x-intercept, the key is that whenever you're on the x-axis, y is automatically 0, because you haven't went up or down. So if you want your x-intercept, you're going to plug in 0 for y and then solve for x. Similarly, if you want your y-intercept, the key is on the y-axis, x is always 0 because you haven't went left or right. So if you plug in 0 for x and solve for y, that'll give you your y-intercept. Here we're going to find the x and y-intercepts of this equation. To find the x-intercept, we're going to plug in 0 for y and solve for x. So if we plug in a 0 right here for y, 2 times 0 is just 0, so we just get negative 3x equals 6. And then we'll divide both sides by negative 3 to get x equals negative 2. That is our x-intercept. That's the place where the graph crosses the x-axis. Similarly, to find our y-intercept, we're going to plug in 0 for x this time. So negative 3 times 0 plus 2y equals 6. This piece goes away, so we get 2y equals 6. And then if we divide by 2, we'll get y equals 3. So that's the location where the graph crosses the y-axis. We can plot these now and graph the line. So we had negative 2 was our x-intercept. That's technically negative 2, 0, because we plugged in 0 for y. And then 3 was our y-intercept. That's technically 0, 3, because we plugged in 0 for x. And if you draw the line through it, you get that equation, or that graph. So this graph represents this equation of the line. Horizontal lines always look like y equals a number. There's no x in the equation of the horizontal line. That means x can be anything. So if you see an equation like y equals 2, that really means x can be anything, but y is always 2. If you draw a graph where x is anything and y is always 2, you get this horizontal line right there. Similarly, vertical lines always look like x equals a number. X equals negative 3 says y can be anything, but x always has to be negative 3. So if you draw a line like that, you'll get a vertical line at x equals negative 3. Here we're going to use the graph to come up with the equation of the line that's shown. For this first one, since it's a vertical line, we know it's going to look like x equals a number, because all vertical lines look like x equals a number. And this line happens to have 4 as the x-coordinate for every point on it. So x is always equal to 4. We get the equation x equals 4. For this other line, we have a horizontal line. Horizontal lines always look like y equals a number. And on this line, you can see y is always negative 3. So we have the equation y equals negative 3. And it's that easy. Parallel lines are two lines that never intersect. So these two lines will always stay the same distance apart and never cross. Perpendicular lines are two lines that cross specifically at a 90-degree angle. Whenever you see the symbol in a corner, that means that is a perfect 90-degree perpendicular angle. Something that's important to realize is that two horizontal lines, like these two red lines here, two horizontal lines are parallel to each other. And two vertical lines, like we have over here, are also parallel to each other. But a horizontal line and a vertical line are going to be perpendicular to each other. So this will help out for the next example. So here's our problem. We want to come up with an equation that fits all these characteristics. So the first thing they tell us is that they want the equation of a line that's perpendicular to y equals 2. They're encoding some information here. Y equals 2 is a horizontal line. And if you're perpendicular to a horizontal line, like we just said, perpendicular means you're 90 degrees to it, that means they're actually talking about a vertical line. So instead of just saying find the equation of a vertical line, they said find the equation of a line perpendicular to y equals 2. You have to know that this is a horizontal line, and that if you're perpendicular to a horizontal, that means you're actually vertical. So that's the first thing we figured out. We want a vertical line. And we're also told that this line passes through the point 3, 2. Let's go ahead and plot that point because we can draw the line that they're talking about. 3, 2 means we go right 3, up 2. So that point should be right about, oops, not there, right about there. And they want a vertical line that goes through that, so we can actually draw that line. Roughly, this is the line that they're talking about. So now the question is, because they want the equation, what is the equation of this line? Well, since it's vertical, all vertical lines look like x equals a number, so we know it's going to be x equals something. And if you look at this line, what does x always equal? For every point on this line, x is equal to 3. So that is the equation that they're after.